Hello and welcome to Tutoring Success, ladies and gents. Today we'll be going over some of the challenging exponential questions again. Today we are dealing with solve for x. So we are going to see what's the difference between simplify and solving for x. So before we begin, allow me to introduce myself. My name is Isaac and I am a civil engineer by trade and a part-time tutor by passion. If you are a returning subscriber, please don't forget to comment and like this time around and give Uncle King Jeff a comment. It's either a bad one or a good one. It doesn't matter, guys. So all we are trying to do is to develop our channel. So even though you are advising me, it's good. So I'll take any advice, guys. And if you are a new subscriber, please feel free to subscribe and be part of our channel. So the very same questions that we are going to ask ourselves today is that how can we make our bases to be the same, So as for simplify and for solve for x is the very same thing, guys. The very first question you ask yourself, how can I make the base to be the same? So as for 2, we are going to leave it like that. So we have 2 raised to the exponent of y multiplied by. So we can write 4 as 2 to the power of 2. We know that raised to the exponent of x minus y divided by. How can we express 8 in an exponential form? So or in a power form? We know that we can write 8 as 2 raised to the exponent of 3. That's 8. So our 8 is raised to the exponent of x minus y equals to 1. So the very same procedure we are going to use today is that we simplify the exponents at the top. We are going to take these 2 and multiply it by x and take it again and multiply it by negative y. Same here in our denominator, we are going to multiply 3 by x and again multiply 3 by negative y. Hopefully I'm understandable, guys. So we are having 2 raised to the exponent of y multiplied by 2 raised to the exponent of 2x minus by 2y all over 2 raised to the exponent of 3x minus 3y. Right? That's 3, guys. I know that it looks like 8, but it's 3. We know that is 3. So from our first rule of exponents, we know that when we multiply the same base, we are going to add the exponent. So in this case, we are going to say 2 raised to the exponent of 2x. Since x doesn't have a like term, so we are going to just write 2x. And then we have negative 2y plus y. So excuse me, guys. So it's the same as saying 1 minus 2. So we obviously know that it's negative y. So on our denominator, we still have our 2 raised to the power or to the exponent of 3x minus 3y equals to 1. So in this case, guys, you can choose to say that, okay, since I'm having a fraction, you can use the second law of exponents, or you can simply just use a cross multiplication. But for me, at this point, I feel like using the cross multiplication is going to be a bit more easier and faster. So we are going to be having 2 raised to the exponent of 2x negative 1 equals to 2 raised to the exponent of 3x minus 3y. So at this point, guys, we have to introduce another law, the last one. So this law only works when you are solving for x. It's another exponential law. So this law states that if you have the very same bases, you just equate the exponents. So I often see my student cancelling the 2 and the 2 here, and then I always tell them that no, they don't cancel each other, but we equate the exponents. So at this point, we are going to say 2x minus y equals to 3x minus 3y, right? So on my first time seeing this question, I thought that no, since we have x and y, that means it's a simultaneous equation. But no, guys, we have to stick to the question. It said solve for x, right? So we must stick to that, guys. We must solve for x, not anything else, not thinking about simultaneous equations and stuff. So okay, at this point I can clearly see that if I can take 2x to the other side, I'm going to get a positive x, right, which is going to say 3x minus by 2x, which is simply going to be x. And then when I take 3 to the other side, it's going to be positive 3y negative y. So it's the same as saying 3 minus 1 or 3y minus y, which is 2y. So if you have any question, guys, feel free to jump on our comment section below and ask your question. So on our next question, we are given this expression, and again the question is that solve for x, and we should stick to that, guys. We need to solve for x, and we need not to forget about this law that we introduced here, that when you have the same base, you equate the exponents. So do we have the same base here? No, we don't have the same base. So we on our first step, we are going to just rewrite 2 raised to the exponent of x multiplied by the root of x, right? So I need you guys your full attention here, guys. Okay, we have 2. This 2 is this 2. So on our sets, we know that when a number it's under the square root, that simply means that its exponent is 1 over 2, right? So we can write this thing as 2 raised to the exponent of 1 over 2, right? So we come back again, we have 2 raised to the exponent of x multiplied by the root of x. And then we go to our first law of exponents. Here we have 1. So since we have 1, that means we are going to, like when you multiply the same base, you are going to add the exponent. So in this case, we are simply going to say 1 plus 1 over 2. How much do we get? You can simply type your calculator, guys. So our answer is going to be 2 raised to the exponent of 3 over 2. That's 3, guys, not 8. It's 3 over 2, guys. It's 2 raised to the exponent of 3 over 2. We still have our x. And then on the next step, guys, we are simply going to take this x and multiply it with the exponent of our base, which is 2. Okay, so we are going to be having 2 raised to the exponent of 3 over 2x. So now we have the very same base. So what do we do when we have the very same base? We are going to equate the exponents. So in this case, we are going to be having x multiplied by the root of x equals to 3 over 2x, right? So in this case, we know that we have x multiplied by x to the power of 1 over 2. Then when we take this x to the other side, we are going to have minus 3 over 2x equals to 0. So do we have a common factor here? Yes, we do have a common factor, which is x. So our first x is we are going to take x outside as our common factor, right? And then on the inside, we are going to be left with x raised to the exponent of 1 over 2 minus by 3 over 2 equals to 0. So our first x here, guys, it's equals why my program is so slow here? I don't understand. My tablet is slow, guys. Okay, so what did we do? We just took this x and we equated it with our 0, right? So in the brackets we are still left with let's just write it as it is, like the root of x. No man, my tablet is slow, guys, but I will try to manage. 3 over 2 equals to 0. So we are going to take 3 over 2 to the other side. So we are going to be left with the root of x equals to 3 over 2. Since, guys, at our exponent we have 1 over 2 at our exponent here, we know that our root simply represents that our x is raised to the exponent of 1 over 2. So what we can do, we can square both sides. You know that when you square, what you do on the left hand side, you are going to do on your right hand side. So in this case, when we square the exponent, that means it's going to be 1 over 2 multiplied by 2, which is going to be 1. So we are simply going to be left with x. And then x will be equals to 3 to the power of 2 is going to be 9. And 2 to the power of 2 is going to be 4. So our final answer, guys, is 9 over 4, and x is also equals to 0. If you made it to this point of this video, guys, you should be a subscriber by now, as I always say. However, I appreciate, I hugely and humongously appreciate your patience and your time, guys. And please remember to subscribe, like, comment, and share.